Well, still say lunch, yeah.
You're recording.
All right, we're back. After that darn bell, okay. So anyway, now, this is a snake. We're going to see where it equals 0. Where it equals 0 would be the roots, otherwise known as the zeros, otherwise known as the what's graphically? X-intercepts. Now, if the snake is high enough, let's say the x-axis was right here. You would only have one root. Let's say this snake is graphed so that the x-axis is right here. You could have 1, 2, up to 3 roots. Now, you can't have any more than 3 roots. It doesn't bend enough, does it? Right? Have you learned before that in a third-degree polynomial you can have up to 3 roots but not more? Have you done that before, Algebra? Maybe? That was actually the #1 mathematician of all time.
Euler.
Mr. Leonard Euler, exactly. He figured out that if you have a third-degree polynomial, you can never have more than 3 roots. Impossible. Okay? And now, there is a case. We got 3 roots, we got 1 root. There is a way to get 2 roots. What if the x-axis is going through here, and it's right at that valley right there? Okay? Yeah, tangent to that valley. Very nice. You get 2 roots, or same with that peak right there. You get 2 roots. So you either get 1 root, 2 roots, or 3 roots. We don't know yet. We're going to find out. Okay? So that's visually what's happening. Some of you are very visual. You can see it. Okay? All right, snake with a bend. Okay, so let's do this. Let's do the rational root theorem. And according to the rational root theorem, all the roots, and you can see this is not very easy to factor. In fact, we can't factor it. So our best shot is this rational root theorem. Plus or minus, on the top we will list the factors of which number?
30.
The very last number. It's going to be 3 parentheses all foiled together is what it's going to be. And you're trying to get that 30. So now don't worry about the minus 30, it doesn't matter. How do you get 30 to happen? Okay, what are the factors of 30? 1 goes in, 2 goes in, 3 goes in, 4 doesn't, 5 goes in. We're not even close to the halfway point of 30 yet, but we're at the square root point, right? What's the square root of 30? About 5 point something. So that means we're already at the mirror. And all you have to do is just take each buddy and create another buddy, and you're done. The reason 5 goes into 30 is because 6 goes in. And the reason 3 goes in is because 10 and 2 times 15 and 1 times 30. Okay? And I usually do the Sieve of Eratosthenes. If I'm working on a problem for your homework, I just kind of go to that square root point and I just start replicating the other half. It's just so much quicker. Okay? All right, over. Now, which factors go on the bottom? The factors of the first coefficient. Okay, that's a 1. And that would only be 1. And the plus or minus will cover if it's plus or minus. Okay? So all the solutions, and we can get up to 3 roots here, are going to lie in this puzzle right here. Okay? Now here's my advice. Start with the small ones. Let's try to find the smallest root first. Okay? Make it easier. All right? And that's why it says try 1. Now it won't say try 1 on your test. You have to write down try 1 for yourself. Okay? Try 1, try -1. Can you see plus 1 over 1 right here?
Mm-hmm.
And -1 over 1? Okay? And the next one was what, 2? Can everybody see plus 2 over 1? And so you just go through systematically, and if you went through every one of these, you would eventually find all 3 roots. Now I'm going to show you a faster way to do it. Let's just find the smallest one first. Okay? So let's see if 1 works. Take 1, and these are all being plugged in for what?
The x's.
These are all x's. So I'm going to take 1 and just plug it in for x and see what happens. Maybe it's a winner. Okay? 1 cubed plus 6 times 1 squared minus 1 minus 30. All right, let's try. What's 1 cubed?
1.
That's 1. What is 6 times 1 squared? 6 minus 1 minus 30. And I see that the 1's cancel. That's nice. What's 6 minus 30?
-24.
-24. Okay, is that a root or not? Is 1 a root? How would you know if you even got a root?
If it equals 0.
If you plug in 1 for all the x's, you get 0 in the end. That's a root. That's -24. Guess what? -24 is not 0. Okay? Most definitely not. That's not a root. Let's try -1. Okay? Everywhere I see an x, I'm going to replace it with parentheses -1. What is -1 cubed?
-1.
-1. 6 times -1 squared?
What's that,
So it'll be
six?
plus 6, minus minus 1,
Plus one.
and then,
Minus six.
okay, the ones just traded places. Okay, then you still get negative 24. Incorrect. Okay, not a root. Now, eventually you're going to get one, okay? This seems like it's long, but this is the shortcut compared to the alternative. This is the one that does not take you a week to do, all right? So, this one just takes a few minutes. Now, I am not going to be mean and dastardly and give you a problem on the test where the three roots are negative 15 over 1, positive 30 over 1, and negative 30 over 1. The last ones you could possibly check. That would be terrible. Okay? I'm going to give you like one of the first couple numbers is going to work. Okay? So just try a couple of examples and you'll say, oh, thank you, Mr. Wade. All right? Let's try 2. Okay? Gee, that's where we ended, so maybe it's going to work. All right? Okay, and we got it right here. Take this, plug it in. Let's see what happens. What's 2 cubed? 8. What is 6 times 2 squared? 24. Okay. Minus 2 minus 30. Oh, I'm hoping. Okay, please work. 8 plus 24 is?
32 minus 2.
Okay. Ooh, 32 minus 2 is 30. Oh, look at it all come together. Nice. We get 0. That means that 2 is one of our roots. Okay? And we can have up to 3 solutions. 2 is definitely one of them, for sure. Now let's see if you truly understand what it means to be a root. Why is 2 a root? If you were to factor this, which we will, you know what one of the parentheses would be to create that 2? X minus 2. Okay? Very good. Does everybody understand that hidden in this factoring right here is going to be an x minus 2 that would create a 2 answer? Right there? Kind of like the front page, or kind of like the last part? Okay? Where it said x plus 7, it gave us a negative 7. So it's x minus 2 times, and the rest of it is some trinomial. Ax squared plus bx plus c, we don't know it. We're going to find it though. Okay? So it's some x minus 2 times some trinomial that creates this right here. And we know one of the hints already, we got x minus 2. Now, if you want a lot of pain and torture, you can go through here and try the 3 and the negative 3 and the 5 and the negative 5 and keep going until you found all of them. Okay? I would hate to plug in 15 by hand into 15 cubed plus 6 times 15 squared, et cetera, et cetera. Not fun, right? Okay, I've got an idea. If x minus 2 is one of the factors of this, what if we take x minus 2 and do a little bit of long division? How about that? What do we do long division? X minus 2 should go into this evenly because it's one of the factors. And if you do long division, you'll find the other parentheses and you'll almost be done. Okay? That'd be very nice. Here's what you do. Down by that long division symbol right there, let's see how many times x minus 2 goes into x cubed plus 6x minus, or 6x squared minus x minus 3. X squared. Okay? How many times does x go into x cubed? That would be x squared. So let's take the, oh, we did this game in the first semester when we were doing the what's, do you remember? Okay, yeah, remember the certain type of asymptote that's called a slant asymptote, remember those? And we did the long, except for, it was long division with a remainder, and the remainder told us what the slant asymptote was. Remember that? Yeah, we would go, whammies. Okay? So, x goes in x cubed, x squared times, the x squared goes right above the stuff. Okay? You have to make an x squared column. All right? What's x squared times x? X cubed. What is x squared times negative 2? Negative 2x squared, and we subtract. Just like we did with long division in elementary school, except for now it's with variables instead of numbers, right? And then x cubed minus x cubed is 0. Perfect, that's what we wanted. 6x squared minus a negative 2x squared is 8x squared. All right, now, something drop down? Drop down the negative x. How many times does x go into 8x squared? That would be positive 8x. Okay, let's see if it works. 8x times x is? That's a match, that's good. 8x times negative 2 is? Negative 16x. And now we subtract. Okay, each level you subtract, right? Okay, hopefully you can see that on camera. This cancels out. What is negative x plus 16x. Positive 15x, drop down the minus 30, let's try it one more time. X times what is 15x? Positive 15. 15 times x minus 2, sure enough, is 15x minus 30, and when you subtract, what remainder do you get? You get 0 remainder. Wow, I'm so surprised.
It's factor.
How about that? Well, you know what? If x minus 2 is one of the factors, it should go in evenly. And if you do this and you don't get a 0 remainder, you did something wrong. Okay? So, now, don't write this part in your paper. Okay? Just kind of observe. But here's what we just did. We just did this polynomial divided by x minus 2 is a result of this trinomial, right? So that's what we just did over there. I just used division bar instead of the long division. Okay? If this is true, and I took this and multiplied it up to the other side, wouldn't our original question equal this times that?
Yeah.
Yeah. So now you can write this part. Didn't we just show that we have these two parentheses right here? So once you find one root with the very clever rational root theorem, you can use long division to find the rest and not have to guess and check all day. And then I will make this very nice and factorable for you, not a quadratic formula. This is handcrafted. Because guess what this is? This is equal to 0, but what is this right here?
X plus
X.
Foil.
Okay, sure. Just undo it and you get 1 and 1.
3 plus 3.
Okay, plus 3 plus 5, that works. You're done. And that is unfactorable unless you use the rational root theorem, and you can do it. Unless you like guess all the infinite possibilities and stumble onto it. I don't want to do that. Okay? And the rational root theorem opens up the doors for us, and you get 3 solutions of 2, negative 3, and negative 5. Voila. Okay? And now you can see why 2 was a root, because hidden in here was an x minus 2 parentheses. Okay? There you go. And that's a shortcut. Compared to the alternative that would take you a couple of weeks for one problem, I do this way.
So you have to find the first one before you can do all.
Yeah, try to find the smallest one, then long division to find the rest that you can factor, and then you're done. And you're done. Okay? Now, we would only do like probably one of these on the next test because obviously they take a while to do. So we would do one. That's it.
12 minutes.
But boy, is this handy. Okay, now, back page goes quickly. Okay, what type of discontinuity do we have for this function? All right. Do you remember the 2 types of discontinuity we discussed in the first semester?
Oh, natural.
Oh, that.
Okay, those 2. And what, do you remember the formal name for it? All right, well, we're about to find out. All right, a little surprise. Okay, this would be a case where I would want to bypass the rational root theorem we just did. Obviously, there's not enough space to put that in there. I'll give you an even shorter shortcut that you can't use on the first page, but you could use for Bromley.